Hi, my name is Jennifer Sills Almeida. Today I am going to be talking about paired sample t-tests, and I'll be going over the verb analysis framework and hypothesis and allowing you to see how everything works. The first thing that I want to do is state the research question. So I'm talking about, is there a significant difference between pre-math scores and post-math scores for students in an intervention program? The step 0 of this is looking at the verb analysis framework. When we are looking at the verb analysis framework, we need to look at keywords. In this sense, it's difference between and pre and post. We are going to have a comparative paired sample t-tests. Within the math subject, we're looking to see if the scores change based on the intervention. The independent variable will be the time period, pre-intervention and post-intervention, and then the IV measurement level would be categorical nominal. The dependent variable would be the mass score, seeing the effect of the mass scores. The measurement level would be continuous at the ratio level. The population would be the same students participating in the intervention program, and the data source would be from the K through 12 worksheet that we're working from the intervention data. So for the test selection, pre-intervention, post-intervention, and we are going to be using the paired samples t-test for the statistical tests. Now, when we're doing this and stuff for steps 1 and 2, we have to look at the null hypothesis. So the null hypothesis was that there would be no significant difference between pre-math and post-math scores for students in an intervention program, meaning it would have no difference. So the mean of the difference scores equals 0. So if it equals 0, then that would be the null hypothesis. But we would have to reject it or have an alternative if there is a significant difference between the pre and post math scores for students in an intervention program. As you can see and stuff, it would be mu for the difference does not equal 0. That is what that means there. And the research symbol, significant difference in math scores between students would be carried over there. Now for the directionality, not predicting direction, we're just asking if a difference exists. The alpha level 0.05 would be signify that it is a two-tailed. The alpha will be set at 0.05. That's the standard threshold in educational research. That means we'll be willing to accept a 5% risk of a type 1 error. So the thing that we'll need to do in SPSS is we'll have to check the assumptions for an independent sample t-test. So what we're going to be doing first is making sure that the math scores, we have a continuous DV dependent variable, which means that the math scores are measured at the ratio level. We'll also, for paired independence, the paired for this and stuff, we have the same intervention programs, same people. What we're going to be looking at is whether the math, the pre-math and post-math scores are altered. Are they different from that when we do that, when we do the statistical testing? The next one is normality. So we need to check whether the normality is violated or not. And we look at this by looking at the difference in the math scores. We'll have to be calculating that. So that is one of the main things here. We're not looking at individual variables. We're looking specifically on the intervention. So what we're going to do now and stuff is we are going to go into transform. So I'm going to open SPSS. I have the form right here. One moment. Okay. Okay, so what we have here, this is the data for the K through 12 intervention data. So over here, what we're going to be doing is looking at the data view. This is all the information that we have. The variable view is going to be the information. The diff math is what we're going to be working with. So what I want to do is I am going to want to see if I could get into the screen and show you exactly how to do that. So when we go to transform, edit, I would like to clear it out first. So it's all brand new and we're going to go to transform. We're going nextly to go to compute variable. So what we're going to be doing is creating that own variable. That variable that we had would be difference in math. So difference math. We're going to call it, we're going to name it that. And it's right here. So once we have that in there, what we'll need to do and stuff is do the post math minus the pre math. So post math would be right here. So we move the variable here, and we're going to put minus the pre math, and we're going to put that variable there. So we're going to compare the difference between what it was like after the interventions. What were the scores of the post-math and pre-math? So how did the scores change after the intervention? And then the intervention stayed the same. We hit OK. Okay, so now you see right here we have that that variable, that 12th variable there, and what we're going to do is just go ahead and put this, name it under the label. So we'll put diff math, and now we have our data view. So if you look over here, now you see that we have another variable that says diff math. So what it's going to do is it's showing the difference in the math scores from the intervention and stuff, after the intervention, pre and post intervention. So it kind of shows you how that has changed. Okay, so the next thing that we're going to want to do is we are going to want to go to analyze, and when we're analyzing, what we're going to want to do is look at these, look at the diff math, the scores for the math, and so we want to go to descriptive, analyze descriptive statistics, and then we're going to want to go to explore. Okay, so as you know, we have created a new variable. It was called diff math. So now what we're going to want to do is we're going to want to look at the statistics of it and see what how it changes when we do have those math scores and stuff. So pre and post. So we put this in there. Now we're going to want to go to plots. Now we want to make sure that we have it on histogram, not stem and leaf. We want to look at normality and factor levels together. So we would hit continue. And then we would hit OK. So we're not going to be doing any other factor lists. We're not comparing multiple groups. What we're doing is we're just looking at the group that we have, which is the people that are in math. The only difference is there's a difference in the times that they're actually, the scores are being looked at, different times, periods. Okay, great. So what we have here and stuff is this is scores and stuff. We actually, what we'll want to do and stuff to explain that again, just one more time, we want to analyze, descriptive analytics, explore. So we are comparing those math scores and stuff. Now, when we went to plots, it is creating a plot for us. So now I am going to be opening up what we have on that. And so you can kind of see here. Okay, so explore and stuff. What we have and stuff is it's just talking about the descriptives right now and what we have for that. So as you can see, what we did is we had the information and stuff. This is the number of the people. Now over here and stuff for the diff math. So again, we're looking at the math scores and the difference for the people that had those. Over here, you'll see the n is equal to 50. We see the mean is 0.70 for a standard error. We see the skewness is 0.452. And also, what is good to note and stuff is normality. So when we're one of the things that we did have to look at was the test of normality. Right here and stuff, as you can see, what we are going to be looking at, which I want to take it back over to the PowerPoint. The normality, what we have here and stuff is we're looking at the numbers. The normality is not violated since the number that I just pulled up is 0.538, and it is not a violation of that because of the fact that it is greater than 0.05 that we had. So this normality is not violated. Now for the paired samples t-test, what we do want to do is we want to go to analyze, compare means and proportions, and we'll also look at the Cohen's d. So I am going to go ahead and do that. So we're going to go to analyze. I do want to get back on the screen over here. Analyze. And what we're going to do is compare means and proportions and paired t-tests. So what we have here and stuff is we are going to want to pair it. And when we compare it, what we're going to want to be doing is the pre-math from the post-math. So variable 1 is going to be the pre-math, variable 2 is going to be the post-math. So we move this in there, then the post-math, we will move that in there, and you hit OK. Now I have just run it, so I'm going to hit that. So it's already up, but I can put it in there again, but you would hit OK, and that's how it would work. And then what will happen is that you'll have this information on what it is. So over here we have the case processing summary, then we have the test of normality, so it's not violated. Then we have the histogram over here that you can kind of see it here. Then you'll see it's normal for the QQ plot over here. It's all along those lines. The trended normal QQ plot, the observed value. And so that one gives us an idea about what is going on there. So what I am going to do, again, I really wanted to show you if we move it into that model. Let me just hit pure samples t-test. And again, I know I showed you this earlier, but I just wanted to really make sure that everyone understand that. So pre-math scores, post-math, over here you hit OK. Okay, so now that we have that, what it pulls up here for you on the t-tests and stuff would be the difference in the scores of the math. Now, as you can see and stuff here, let's look at this. So before the intervention for pre-math, the mean scores of the students was 54.29. After the intervention, the post-math scores was 58.645. So this actually resulted in a change, a mean of 4.35. So that means the score went up 4 points, which is good. Standard deviation was 6.26. The standard error is 0.885. So when we're looking at this, what we're looking at is whether or not, it made a difference. So first of all and stuff, what we do need to look at is when we're looking at the P numbers. I am going to go to the what I want to do is I want to go over to, since we've run analysis, I want to go over to this paired t-test and kind of look at it. It's the same numbers as before, but it's all in one on page. So the pre-math scores, like I was saying, was 54.29. Post is 58.64. The paired correlation value is 0.751. So this number, what it means is the closer we are to 1, the closer the correlation is. So it is important to know that for the paired samples t-test, for this one over here, the paired samples t-tests and stuff, the difference between the pre and post is 4.35. So it shows you right here. And the negative 6.179 is a good magnitude that it shows you. It's indicated right here. The DF is 49. The two-sided P is well below this one of 0.05, so we will reject the null. For Cohen's d, what we'll do is we'll take the 4.35, you divide it by, when you divide this by the Cohen's d of 4.97, what we are going to be getting is that 0.874. Now, so this results in Cohen's d of 0.874, and this is a substantial effect. So we have to make a decision. Do we have a highly significant p-value less than 0.0001? And since it was less than the alpha of 0.05, yes, it was significant. We're rejecting the null hypothesis since there was a significant difference between the pre and post math tests. We have Cohen's d. What we did is we divided the 4.35 by the 4.97 that I just showed you over here, put the mean of 4.35, and then divided by the Cohen's d, and then we got that negative 0.874. So what this means over here for us is that we have to see, does it have a big substantial effect and stuff, significant effect? Well, we know that there's three different things. For Cohen's d, it's a small effect, a medium effect, and a large effect. Well, our number of 0.874 is a large effect. It's even over 0.8. So we know that the Cohen's d size is large since it is greater than 0.8. Now, over here and stuff, what we are going to want to look at is a paired sample t-test was conducted, that computed the math scores before and after intervention in participation intervention program. So over here, the post-intervention math scores was for that and stuff that we have is right here. So I want you all to look at it again. So before the venture, it was 54. After the intervention was 58. So if we go over here and look at that, what that means is that the standard deviation, there was 7.47, and it was higher than the pre-intervention math scores. So as you can see, the pre-intervention, the scores were only at 54, the mean score. Later on, it was at a 58. Mean score because of the intervention. So this shows that this was significant. Now, the practical significance of this for the effect, we already know that with the Cohen's d, it had a 0.874, which was a large effect size, right? Just showed you this, right? So 0.874, which is over 8, and that's a large effect size. And what this means in practice is that students overall, they gained an average of 4 points on math scores after participating in the intervention program. So with an effect size of 0.874, it's a meaningful, substantial improvement, not just a statistical artifact. So what this means is that if a school wanted to do this intervention, then it would be a good one. It would be a good investment because of this. It had a strong, significant effect size, and also the Cohen's, for the Cohen's d. Now, the practical significance is that it both has a statistical and practical significance, and this is due to the p-value less than 0.001. It tells us the improvement is real, and the effect size of 0.874 tells us the improvement matters. Now, there is no control group, so what that means is that we can't say the improvement is only from the intervention. It could be from other effects like practice effects or other instructions. But we do know that that with the Cohen's d, it is showing that it is highly significant. So that is why we are going to do that. That was step 6, and that's practical significance. So that is where we were at with that. And hopefully that all makes sense in regards to how that's playing out. And I hope this makes sense. So again, to run through it one more time on the t-test, just like to go back here. I was on PowerPoint because I wanted you to see all different the wording and everything and how it all comes together. But again, the mean pre-math scores was 54.29. After the invention, the post-math scores was 58.64. The correlation, since it's close to 1, is pretty correlated to one another. And the mean scores where it increased from, 54 to 58 was over 4 points. So that means the intervention was successful. And for the Cohen's D was negative 0.874. So that has a large effect size, and it has practical significance because of the p-value was less than 0.001. So the improvement was real. Thank you very much. I hope this was very informational for you. Bye.